our main discovery is that there is a switch that animals use to go from being normal weight to overweight. That switch, you can activate it by certain types of foods.
Dr. Rick Johnson, welcome to the show.
Thank you so much. I'm delighted to be on your show.
I'm so excited. Your book is crazy. So the title alone grabbed me. Nature wants us to be fat. That is certainly how it feels.
Yeah, it's certainly a bad title in terms of what it carries for us. But
yeah, if only it weren't true.
If only it weren't true.
So getting into it, there's a lot going on. I think it's really interesting. I think it's going to profoundly impact how people approach, if not, hopefully their life, but if nothing else, the debate around, is it just calories? Do the types of calories matter? Which is a debate that I've sort of been dancing on the periphery of for the last probably decade plus. I don't care what the answer is. I just want to know what the truth is. So I'll ask point blank, is it just a calorie question why we get fat, or is there more at play?
Oh, there's a lot more at play, but calories are clearly important. They are important, but the type of foods make a huge difference, whether or not you're eating protein, fat, or carbs. And then within the protein, fats, and carbs, there are good proteins and bad proteins, good carbs and bad carbs. And then even there, if you have a bad carb, the way you eat it can make a difference. So it turns out.
Can you define what makes something good, what makes something bad?
If it tries to drive a process that wants to make you gain weight. So it turns out that our main discovery is that there is a switch that animals use to go from being normal weight to overweight. That switch, you can activate it by certain types of foods. And not all foods activate it. And it's a specific pathway. We've actually identified the very steps in that pathway. And the incredible thing, the more we study this, the more it appears that this is a pathway that's driving not just obesity and diabetes, but that it's involved in a variety of diseases, including dementia and cancer and behavioral disorders and high blood pressure and kidney disease and liver disease. I mean, I feel very fortunate that I've fallen on this. And we've been doing studies for now about 25 years, but as it gets stronger and stronger, I realized that I needed to write about it. And so...
what's the pathway called, by the way?
Well, I call it the survival switch, because it's a basic process animals use to try to protect themselves from time when there's no food. So for example, most animals will regulate their weight very tightly. So if they eat,
how do you know that?
For example, like if you take a laboratory rat, or if you take an animal in the wild and you catch it and let's say you force feed it, you make it gain weight, and then you quit the force feeding and the animal will come right back to its weight. And not only that, it'll come back to the weight it's supposed to be at that time of the year.
Whoa.
Yeah. And likewise, if you take the food away from an animal and it loses weight, you give it back food and it will go right back to the weight it thinks it should be at. And so normally animals regulate weight really, really well. But there are some animals that when they know that there's going to be a problem, like winter's coming, like, I got to fly 12,000 kilometers nonstop to get to my where I'm going to head for migration. When they know that, they will suddenly start gaining weight dramatically. A bear can gain 8 to 10 pounds a day.
Whoa.
Now,
so let's
20,000 calories.
How do we know then that, because you said the animal will go back to the weight that it's supposed to be for that time of year. So how do we know that there's not like a weight clock in the way that there's a circadian rhythm clock?
Good question. So we figured out that there's a food that triggers this. So normally weight is regulated by a hormone called leptin. There are other regulatory hormones too, but this one is a big one.
So it's not a shift in metabolic rate, it's a shift in hunger levels?
Oh, it's both. It's a whole orchestrated event. So what happens is It turns out that the main way, a major way that it's done is by eating fructose, which is a sugar that's in fruit and honey. And when an animal started eating fructose, it activates this metabolic pathway. You have to eat a lot of it. It's not like you and I eating an apple, okay? It's like, like a bear will eat like 10,000 berries like at one setting. It's really like you have to eat a large amount of fructose. And when you do, it triggers this switch that makes you hungry. It makes you thirsty. It affects the brain centers. You can show where it affects it. And it will want you to do foraging behavior where you go out and seek and try to find food. But while you're foraging, your activity continues to be good, your metabolism's good. But when you stop foraging, your resting energy metabolism actually goes to a lower level. So your basal metabolic rate, or your how many calories you're spending in a day, the foraging will cause you'll spend calories foraging, but when you're resting, you'll actually spend less calories. You stay more quiet than a normal animal.
So really fast, there's an idea that was introduced to me that made intuitive sense. The idea was that when we're eating, food is really a signaling molecule. And so it gives our body certain signals. And what you're saying is that eating fructose signals to our body that, hey, winter is coming, prepare for this.
Yes.
And so we've co-evolved with plants. Plants, for their own reasons, want us to eat their fruit.
Right.
But we have evolved to really go hard on fruit at the time of year when it's actually available, because the next thing coming is fall and then winter.
Right.
And so those who responded to the signal of fructose by lowering their basal metabolic rate, beginning to store fat, and we'll get into like some of the processes that quote unquote break, but it's actually beneficial in terms of the people that had this response, got fatter when they ate it, they sought out more food, their basal metabolic rate went down, they started storing fat, there's this whole host of things that happen, and because of hard times, most people that didn't have that response died. And then
That's right.
the people that did, they were able to survive. So for most of the episode, we're gonna be talking about this as if it's bad, but there's actually a reason
Yes.
why this happens. And for me to think about food as a signaling molecule rather than just calories in, calories out was really helpful.
That's right. So it turns out that there is this symbiosis with plants. You had mentioned this first. So, so plants will, the fruit trees will, a lot of times the fruit will ripen in the fall. And that's at the time when the animals are trying to gain fat. And so when they ripen, the sugar content goes up, the fructose content goes up, and the seeds mature. And things like vitamin C and things that actually block the effects of fructose, block this pathway, go down. So the vitamin C levels go down, the sugar goes up, the fruit drops, now the seeds are mature, the animals eat the fruit, and then they disperse the seeds in their poop, and then you have, it's great for the plants because now there's more trees, and it's great for the animals because they can put on fat. So it stimulates fat. It also stimulates insulin resistance. And insulin resistance, I used to think of it as pathologic. You don't want to be insulin resistant. But if you're an animal, insulin resistance means that the glucose in your body can't get into the muscle very well, because that requires insulin to get into the muscle. But most of the brain does not require insulin. And so it leaves the glucose for the brain, so you can, which is what you want to do. If you don't have enough fuel, you want to shunt the fuel to the brain, because if you can't think, you're going to not do well. So anyway, so this switch is activated by fructose, and the way it works is it drops the energy in the cell. I know that sounds funny because all calories create energy, but you have to think of, when I say drop the energy in the cell, I mean the active usable energy. So when you eat calories, basically it can go into stored energy, which is fat for the most part. And it can go into active energy, which we call ATP. And the ATP is what you and I use to talk, to think, to walk. I got here using my ATP. I walked in because I have ATP going. And so ATP is your immediate usable energy. And so what it does is the ATP normally comes from the energy factories in the cell. We call them mitochondria. And really, this is totally it. If you're into health, you want healthy mitochondria. Mitochondrial health, they make the energy. And obesity is an energy disorder, and diabetes is an energy disorder. So these little mitochondria are pouring out the ATP. But there's an ancient system too called glycolysis, which can make ATP. And so that there's another system which rarely kicks in. So mainly it's these energy factories. And what this switch does is it depresses the mitochondria. It depresses, and it does it by causing like oxidative stress to those mitochondria. And so the amount of ATP there's less ATP being made. And so the calories are shunted to stored fat instead of instant fat. It just shunts it. It shunts it from instant energy to stored energy. And the stored energy is the fat. It's a brilliant system.
So why through oxidative stress to the mitochondria what is shunting? Because I'm assuming you mean the calories. So the calories, instead of going to produce ATP, are going to be stored as fat.
Right.
What mechanism in the body is saying why? Because there's some mechanism that's saying ATP, the production of ATP has become inefficient. We're better off storing this as fat.
So the way ATP is produced is, there's breakdown products that go into a thing called the citric acid cycle or Krebs cycle, and then it moves on to to oxidative phosphorylation, where you produce the mitochondria start producing a lot of ATP, and they require oxygen. A lot of the oxygen we breathe goes to make the ATP. And what happens is some of the enzymes in these cycles, the things that kind of move the stuff around and break it down to the next step, and so that it can make ATP, they're sensitive to oxidative stress. So that if there's oxidative stress goes up, those enzymes get inhibited. And so that pathway to make ATP is slowed down or reduced, or it's not fully stopped, but it's like slowed down. And so when that happens, the mitochondria make less ATP. So it turns out that there's more shunting. Some of the metabolites actually go and stimulate fat production, and also to block the burning of fat. So it stimulates both the synthesis of fat and it blocks the breaking down of fat. And so it's like a double whammy. And so what happens is the calories end up getting stored as fat, and the amount of energy produced is less. And then what happens is the low energy makes you hungry. So then you eat more, and so it stores more fat because it's the shunt still going on. But eventually the ATP levels start coming up because you're eating more and more. So it's a brilliant system. And when we first discovered this pathway and realized it was orchestrating the whole series of events, then we realized that there was another side to it, which is that the body can make fructose. This is even worse.
That was maybe one of the most shocking things in the book. And it bears explaining to people what made you ask that question in the first place. Because if I look at this with the hat on of like, hold on, you're just violating the second law of thermodynamics. Like, you have to be overeating in order to put on fat. And so walk people through, why did you start asking that question in the first place? Why, when you discover that fructose makes people fat, why weren't you like, we're done?
Yeah, listen, so there are two questions you just brought up. So if you don't mind, I'll answer the first one, which is the law of thermodynamics. And it gets back to the calorie question, okay? So when we found that animals who were eating fructose started to eat more, and they got really fat, and they got diabetic, and they got fatty liver, and they got their triglycerides went up to their blood, and they develop low-grade kidney disease. I mean, it was like, this is coming from sugar, I mean, oh my God. Lustig calls sugar poison. I understand why, because when you put this into overload, you really create a monster. But anyway, so the question was, well, is that because they're eating too much, because it's stimulating hunger? But what if we made it so that all the animals ate the same amount of food? So even though you're hungry, I'm not going to give you the food you want. So what we're going to do is we're going to feed all the animals the same amount. And then we had a control group and a high sugar or fructose group. And I should say that sugar has fructose in it. So table sugar, high fructose corn syrup, these are the main sources of fructose for us. So when we did that and we took those animals and we gave them exactly the same, so it turned out, remember how I told you that it makes you hungry and eat more, but it also drops your resting energy metabolism. So because it drops your energy metabolism, if you're eating the same number of calories, there will be some weight gain in the sugar group. Also, we did a trick where we gave them less calories than they normally eat. So they were like on a diet, but one's on a high sugar diet, one's on a control diet. And when we put them on the high sugar diet, those animals became diabetic. They got fatty liver. They developed high triglycerides.
Did they store body fat?
They had more body fat, but their weights were very, very similar. Because of the lower energy metabolism, they actually were about 10 to 20 grams difference in weight. They actually, even though they were on a caloric restriction, they gained 10 grams and of weight. These are rats, so 10 grams isn't anything for us, but if you're a rat, it's a little bit more. So they gained weight, and the other group lost weight. So, but it wasn't statistically significant. So in our paper, we had to say there was no statistical difference in weight. Yet, despite no statistical difference in weight, there was a dramatic difference in everything else. They became diabetic. So there's two pathways, right? So one is, yes, if you go on a high sugar diet and you also go on, have a high fat in the diet, the fat is actually playing a role because the high sugar makes you hungry and makes you lose control of your appetite. But the high fat is like super high calories. And so you gain weight very fast. If you just put an animal on a high sugar diet, they gain weight, but it's it takes a lot longer. But the fat is like the firewood and the sugar is like the fire. So if you take away the fire and you go on a low carb diet and you are on high fat now, well, there's no stimulus to gain weight because you've taken away the fructose. Okay. And so the answer to your question is, yes, calories are important, but also there's something special about fructose where even if you're on a caloric restriction, it's going to make you diabetic.
That's crazy.
Yeah.
So there's all these knock-on effects of having the fructose, but the part where I was like, okay, what you're saying makes a prediction that if I'm just eating glucose, for instance, which literally until the idea of uric acid and all this stuff, which we haven't even got to uric acid yet, until all of this got on my radar, I would have said that, okay, fructose maybe is a little bit worse because it can only be stored in your liver and your muscles, and so you just don't have a way to use it, but that glucose would be terrible as well.
Yeah. Well, so you got me. So, so this leads into the second part of your question, and that was, okay, so what made you realize that fructose was being made in the body? And, originally, so I when the first data came out, I said, okay, fructose is the bad guy. And I even published a book, the first book on a low fructose diet called The Sugar Fix. And some people lost weight great and some didn't. And I was on an interview with Jimmy Moore, and Jimmy says, hey, Rick, I know that sugar's bad, but I have to cut out bread and rice and potatoes to lose weight. I have to do full carb restriction. And I was pretty aware that bread was fattening and French fries, they couldn't be good, And also there are a lot of animals in the wild that get fat and they're not eating fruit, And so the question—
Can you give us an example?
Oh, like for example, a whale. They're the fattest animal. I haven't seen one eat a banana. They probably would eat one, but anyway, we knew that the body can make fructose. This was known for 50 years, and so fructose can be made in the body. There's only one way it can be made, and it's through a thing where an enzyme has to be turned on. And it's called, it's the polyol pathway it's called. But normally it's pretty quiet. It's not present. So when you're young, it's not really around.
Do we have a sense of why that would be? Like, why are kids, because they're already storing more fat? Like, I don't understand why, if there is any benefit that led us to producing fructose, which I'm assuming there is, why it wouldn't be present in kids.
Well, I think that fructose is really this whole pathway is turned on in situations of stress.
Okay.
So if you're not stressed, so if the baby is being breastfed and everything's going fine, it's going to have very low levels. But you can turn it on. It can even go up locally with stress. Like when you have a heart attack, the heart cells will convert and start metabolizing and making fructose.
Why?
When the heart starts to make fructose and turns on the enzymes to make fructose, it tries to turn on the switch locally. And remember that what it does is it suppresses the mitochondria. And the mitochondria are using a lot of oxygen to make ATP.
Can I use the phrase that you use in the book?
Energy factories.
You call this the alarm bell.
Oh, yeah.
And I was like, okay. So, and that made sense to me. So alarm, winter's coming. Alarm, you just had a heart attack. And so if this is the body's alarm bell, then I would understand why it would be produced locally. I don't yet understand why fructose, but...
Yeah, so what happens is when the fructose is produced, it causes that oxidative stress to the energy factories, and it reduces the oxygen needs. The mitochondria become less active, so they consume less oxygen.
That's why.
And so it's trying to protect the heart.
Because in a heart attack, you would have less oxygen.
Yes, because
present.
the blood supply has been impaired.
Got it.
So there's less oxygen. So it's trying to help you. And then shifts it to this primitive system to make energy. And this primitive system doesn't make a lot of energy. And so what happens is it might be protective for a few minutes, but over time, it actually leads to thickening of the heart, hypertrophy, disease of the heart. And this has been also been shown, like in the kidneys, and if you have acute kidney failure. Again, the fructose system gets turned on in the kidney, and it tries to protect, but it ends up causing inflammation and fibrosis and all these things because we have an exuberant response. And one of the reasons we have that exuberant response is because of uric acid. But getting back to the very basic question, so when I originally thought, okay, the answer is we can just cut out fructose in the diet, but then I realized that carbs could do it that did not contain fructose. And then I realized that myself and Miguel Lanaspa, who I work with, the two of us were having a discussion, and we realized that when you eat a high glycemic carb, you could theoretically start making fructose in your body. And the reason that is that one of the classic means for stimulating fructose turns out to be from a high glucose level in the blood. So if you're diabetic and you have a high glucose level in the blood, it had already been reported that stimulates fructose production. So people with bad diabetes have a lot of fructose that they're making. And the fructose is playing a role in their kidney disease. We can block the kidney disease from diabetes by reducing or blocking the effects of fructose. So it's pretty cool. So since high glucose can stimulate fructose production, we realize that every time you eat bread or rice or potatoes, the glucose in your blood goes up a bit, and it stimulates insulin, but it might stimulate fructose. And so we did these experiments where we put animals on glucose, and I was originally thinking they wouldn't get fat, but you're right. They got really fat. They were waddling around. I mean, and so then we gave the glucose to animals that could not either make fructose because we had genetically removed that enzyme, or they couldn't metabolize fructose, so we genetically removed that enzyme. And when we could do that, they could eat the carbs, and they gained a little bit of weight. They did gain modest weight, but they didn't get a big weight gain, and they didn't get the fatty liver, and they didn't get insulin resistance, and they were really protected.
What's up, everybody? Tom Bilyeu here, and I have a question for you. At the start of this year, you likely set some goals for yourself, and I want to know how those are going. Most people give up on their goals and dreams by February, but I have some good news. If you're not on target to succeed at the things that you want to achieve this year, it's not too late, and trust me when I say you are not alone. Everyone gets stuck and loses momentum towards their goals at some point, myself included. If you know what you're doing and you're willing to take massive action though, you can get back on track. The trick is not to think about being stuck as a problem with your motivation or to interpret your lack of results that you're getting as a sign that you're not smart enough. The trick is to recognize that the game that you're playing is a game of neurochemistry. It's about managing the way that you think about yourself and framing things in the right way. If you use your brain more effectively, repeat things that empower you, you can actually find ways to solve problems faster, create positive habits and behaviors that you know are going to help you reach your goal. I want you to take massive action right now, so I've pulled a workshop from Impact Theory University called the 6 Steps to Getting Unstuck, and I want you to watch it right now. It's gonna help you get back on track with your goals and make the rest of this year your most successful ever. To watch it, go to unstuckclass.com and register for access. I'll walk you through the same process that I use to get through obstacles and make fast progress towards my goals whenever something slows down. All right, guys, enjoy this and be legendary. Take care. So basically, if you don't produce fructose or you can't metabolize the fructose that's there, you won't have this exaggerated response.
Right. Yeah, and there are people who lack that enzyme, and none of them have ever been reported to be obese or diabetic.
Very interesting.
They are completely healthy.
So if fructose, though, is the alarm bell, why do you think glucose triggers the alarm bell?
Well, it's a good question. So it turns out that when the glucose level goes up in the blood, it creates a sense of dehydration. And you probably know that people who are diabetic are often very thirsty and drink lots of water. And it also turns out that dehydration is the biggest stimulus for fructose production.
More than eating glucose?
They're about the same, but eating the glucose makes you, stimulates a sense of dehydration. And so, but what happens is that what triggers the production of fructose is if you start becoming dehydrated.
I know the punchline here.
Yeah.
That's interesting. Okay, keep going. But now that I can predict where the problem comes in, that's really, keep going?
Yeah,
I'm almost certain I know what the answer is here.
Yeah, so it turns out that a lot of animals use fat not just as a calorie source, but as a source of water.
Yep.
Because when you burn fat, you produce water. So the camel has the fat on its back that breaks down the fat in the hump when it needs water. And the whale doesn't drink salt water, so it gets its fresh water from the crustaceans and things it eats, the fish and stuff it eats. But it also gets the water from its fat. There's even a primate, a dwarfed fat-tailed dwarf lemur. And that guy lives on it will hibernate, or they call it estivation, but it's like hibernation, like 5 months during the dry season, and it will use its fat to produce water. So it turns out that fat is a source of water. So when an animal gets dehydrated, and particularly if they're worried that they're going to become dehydrated, they will start to gain fat as a source of, as a way to help give them water during the times of need. And the best way to do that is like to create a little bit of dehydration. So if your glucose levels are high, that's one way. But if you a deer and you're looking at a salt lick, that would be another way, because when you take salt, the salt concentration goes up in the blood, sort of like the glucose concentration, and that triggers thirst. And
That's
so
crazy.
boom.
So when a deer or a cow is licking a salt lick, it's a way to trigger in their body the storage of fat as a protective mechanism against basically either famine or lack of water.
Yeah, so deer, they eating a lot of grass and stuff that's calorie poor. So they need stimulus to help them store adequate amounts of calories. But what we did do, though, is we took we did studies in people, so maybe that's more relevant. So what we did, well, first what we did is we did a study in animals, and we put them on a high salt diet. And salt, people know that salt's associated with blood pressure, and heart trouble, but no one really had linked salt with obesity in the common literature, you know. But there were, in the medical literature, there was some studies showing that people who eat a high salt diet are at increased risk for obesity. And there's like 10 studies out there. And so it seemed kind of odd. How would salt, which has no calories, increase your risk for getting fat? But when we put animals on salt, it raised the salt concentration in their blood. They became thirsty, of course, and they started eating more. And after several months, they became hugely fat, diabetic and everything. And then if we...
Just from salt?
Yep.
You didn't increase their
No.
glucose, didn't increase their fructose?
No.
Just
they weren't
salt.
even getting any fructose. They were just on normal chow, and they became hungry. They lost their control of appetite. They started gaining weight, and they became diabetic, and they had fatty liver.
Off of salt?
Off of salt, just increasing salt. Now, we'll get there in a bit, because I know we're going to talk about salt in terms of how modern diets and the low-carb diet, so we can get there. But anyway, so what happened was they were making fructose. The salt activated the enzyme that converted glucose to fructose. So the glucose that they're getting from their chow was being converted to fructose very easily because the salt really turned it on. So you didn't have to have a high glucose in your blood. It was just enough to just turn it on, and then what glucose you have, a lot of it's being converted to fructose. And so what happened was, if we blocked the fructose, we could block the fructose production or the fructose, the breaking down of fructose. And when we did that, they could eat all the salt they want, and they didn't get fat.
Wow.
And what's more, they didn't even get high blood pressure. So the high blood pressure was going through that pathway. So then, we looked at people, and we found that high salt diet also predicted fatty liver and obesity and diabetes in people, and so along with others. And then there's a group that discovered that there's a hormone called vasopressin, which goes up when you're dehydrated. And so all these animals in the desert have high vasopressin levels. And vasopressin is a hormone to help you hold water. And it's high in people with obesity. So everybody in fact, Jody Stuckey, this wonderful scientist, found that people who are obese, depending on what measure you use, they can be 12 times more likely to be dehydrated than a non-obese person. That's using a thing called bioimpedance. And if you measure, the classic measure, which is the salt concentration in your blood, people who are obese are 2 times more likely to be dehydrated than a lean person. And so it turns out that a lot of people who are obese are not just eating bad diets like sugar, they're eating a lot of salt. And the salt is activating this pathway to make sugar, to make fructose, and to metabolize fructose. And so what's going on is there's a another secret driving mechanism for obesity. So now we know that high glycemic carbs can do it, and we know that salty foods can do it. But the way salt works is it works by converting the glucose in our body to fructose. So if you're on a low-carb diet and you're eating salt, you're going to make less fructose because you just don't have much glucose around. So a lot of people who go on a low-carb diet will actually eat kind of a lot of salty foods, and they don't get fat because they don't have the glucose to convert.
This is so interesting to me, the way that this is all working. Okay, so we've got the salt is triggering the enzyme that allows us to turn glucose into fructose. And the reason that our ancestors who did that would have been more likely to survive is because for us to be in that kind of situation, it means that there's a drought coming, so we may not have access to either enough food to get water out of the food or enough direct water to stay hydrated, and therefore triggering the alarm system and making sure that we store fat so that we can repurpose it as water becomes a very meaningful thing. That's insane, but okay. Glucose can be turned easily into fructose. Again, this is the alarm system. Why glucose triggers the alarm system, though, that's purely because I'm getting dehydrated. Why though? Does it actually dehydrate me, or is it dehydration-like? And if it's dehydration-like, why is glucose in and of itself problematic?
Okay, well, so when the glucose is high in the blood, it does create a sense of dehydration. And
Is that the only problem? Because that to me
no,
feels
because
like
it also mimics a thing called insulin resistance. So if you eat most starches, for example, or vegetables or things like that that have glucose in them, many of them are not going to trigger the switch, because the switch only gets activated when the glucose levels are high, when the glucose levels are high, it makes the animal feel it's dehydrated.
Mm-hmm.
So classically, dehydration, we talk about dehydration as a loss of water. And so, you have diarrhea, or you're vomiting, or you're sweating too much, and you lose water and you become dehydrated. So we usually think of dehydration as a loss of water. And when you lose the water, the concentrations of salt goes up in your blood.
Because the water's been stripped out.
Right, because the water's been stripped out. You can mimic dehydration. It's really the same thing as dehydration by eating salt. Because when you eat salt, the salt concentration goes up, but you haven't lost the water. So it's kind of a pseudo dehydration, because you didn't lose the water, you gained the salt. But it's the same effect. The animal wants to keep the concentrations of salt and glucose normal in its blood, because it allows a movement in and out of the cells. I mean, it's really important in how transport works. Now, if you eat most foods with starch or glucose, the glucose concentrations don't go up much. But if you eat high glycemic carbs, and you eat like a lot of potatoes or rice or something, then your glucose can go up right after the meal. And we can show that with like a continuous glucose monitor.
Yep.
And when the glucose goes up, for some reason, this pathway to make fructose is activated. I don't absolutely know why, but I know that there's what we call an osmolarity trigger. And when an osmolarity is a name for the concentration of glucose plus salt. So when the glucose goes up and the osmolality goes up, or the concentration of the blood gets higher, it makes the animal feel it's dehydrated. And it is actually a type of dehydration. It's just that you're not losing water so much as your glucose is going up, and the concentration of electrolytes and glucose go up in the blood. Now, when you're diabetic, you're also peeing a lot of urine, because the glucose gets into the urine, and so you are becoming dehydrated based on that. So, but it's sort of an argumentative point, but when you eat, if your glucose goes up in your blood, it triggers the production of fructose.
Okay, so the thing that I'm trying to make sure that I understand is why the body would care about that. So it seems to me like fructose is just the mechanism of action, but it's really anything that's causing an imbalance in my blood that the body cares about, basically. So if I've got too high of a concentration of salt, then my body's going to trigger fructose. If I've got too much glucose in my system, my body's going to trigger fructose.
Right.
So it's whenever my blood is getting out of balance, I'm triggering this alarm system.
Whenever you're thirsty. So the commonality is that when this goes up, it creates a dehydration type of picture.
And dehydration, by definition,
means you're going to be thirsty, and you're going to release this hormone vasopressin. So
okay.
All roads that lead to Rome involve fructose. So it's either the fructose you eat or the fructose you make. If you eat a lot of fructose, you're going to activate the switch.
And Rome, just so we're clear, is metabolic disease.
That's the switch where you turn on to become diabetic and all these things. So when you eat a lot of fructose, that will do it. If you become dehydrated, like with salty diets and so forth, that will do it. If you eat high glycemic foods, that can do it too. So those are like the three main ones. And it turns out that the way the fructose works is it works through the production of a substance called uric acid. And the uric acid is, it's a normal substance that we all make. All animals make it. and when you make it, then you have to excrete it. And most animals excrete it by breaking it down. But we lost our ability to break it down during 15 million years ago. And so all humans have a higher uric acid than than all other mammals. Apes also have this mutation. So anyway, so we have a higher uric acid. And this makes us more sensitive to the effects of fructose, because fructose is working through uric acid. And when we can't break the uric acid down and fructose makes it, the uric acid shoots up higher than it normally would. And when that happens, we become very sensitive to sugar and to all of these pathways. So a normal animal has to eat even more fructose than we do to really get the effect. And we are very sensitive to sugar. And so the uric acid is the thing that actually causes that stunning of the energy factories. And so the uric acid is playing a key role.
So uric acid is the oxidative.
Yes, that's what causes
damage.
The oxidative stress.
Okay.
Too. It's the main guy. So it helps orchestrate that drop in energy in the cell. And when that happens, when the energy goes down, there's the alarm signal, you trigger this huge switch, and animals want to gain fat. And so the problem is we had this mutation because it occurred during a period of famine. It was probably important for us to survive. And now we have this mutation, so we're sensitive to sugar. And now we're getting tons of high fructose corn syrup and table sugar, and it's being put in our food. And we have salt being put in all this processed food. And then here's the terrible twist. It turns out that uric acid has its own taste too. So we have 5 tastes.
That we like.
Yes, that we like. So there's sweet and salt. We like those. Sweet, that's to get fructose. Salt, that's to trigger the production of fructose. Then we have bitter and sour, which are to, tell us not to eat those foods. And then we have umami. And the umami is called the 5th taste. And it's this brilliant taste. It's like a savory flavor. It's what, in gravies and beef extracts and the drying and curing of meats, leads to this really delicious flavor. It's in beer. It's the yeast extract in beer. It's in tomatoes, believe it or not. And the Bloody Mary is a perfect example of a nice umami food, beer. And it's in organ meats. It's in blue cheese, when you have that delicious blue cheese salad.
Blue cheese freaks me out, so I don't know about that one. But.
Okay. Well, I like it. Caesar salads and the anchovies. So what it is it turns out that when they figured out what umami was, the thing that activates umami is an amino acid called glutamate, or MSG. And when you eat glutamate, guess what you make? Uric acid.
I was going to say, yeah.
It's terrible. And it's also stimulated by a substance called AMP and IMP, which are breakdown products of ATP. And when you activate this switch, the ATP is broken down and you make the IMP and AMP. The switch makes these substances that are part of the umami flavor. And so when we give animals umami, and we give them umami in the drinking water, so they get a high concentration, they also can become obese. And it's because they enter into this pathway after fructose. When you eat fructose, you make uric acid. And when you eat umami, you kind of bypass the fructose, but you still make that uric acid.
You make it, or it's now present because you've just eaten it?
No, it's made from the glutamate and from the IMP, and it's upstream. So it actually will generate uric acid.
So, okay, now is MSG more potent than even fructose?
Yeah, so if you do it gram for gram, MSG is more potent than sugar. But we don't eat very much umami. So the average person's eating, a few grams of umami a day, and you're eating grams and grams of sugar. So there's a huge difference, right? So in the potency, sugar's number 1. High glycemic carbs are probably number 2. Salty foods are a distant 3. and umami is maybe even a 4. But the whole thing's kind of interesting. So and the fructose, when you eat it, is acting to activate this survival pathway, which is supposed to be beneficial. But when you're in overdrive, because you've got the mutation and all this, now it's driving obesity. And so the newest stuff is that we're now showing that this pathway is like involved in things like dementia and so forth. And that when in Alzheimer's, there's evidence that the earliest problem is insulin resistance in the brain. And the brain doesn't normally need much insulin to get glucose, but there's certain parts of the brain that do require insulin, and insulin resistance to those parts can be the earliest sign of Alzheimer's. And you can show that in people with Alzheimer's that they're making fructose in their brain. You can show that they've activated the pathway. You can show that fructose causes insulin resistance in the brain. It drops the energy in the cell. And in Alzheimer's, the ATP levels are low. They have mitochondrial problems. They have all the markers. So what's happening is Alzheimer's, I believe, is actually being driven by this pathway. Salty foods, high glycemic carbs, chronically can cause this. The other thing I should mention is that what we know is like this fructose sort of initiates this, but over time the mitochondria will actually, or the energy factories, get less and less and less, because initially when you do this, there's just this transient oxidative stress and the switch is turned on, and then you stop it, the switch comes back, the switch is turned off and everything's fine. But if you keep hitting it again and again and again and again, over years, what happens is the mitochondria actually get weakened, and it's like involved in the aging process, and as the number of mitochondria go down, then what happens is it resets your body weight to a higher weight. And so what happens is now when you try to lose weight, you can lose the weight, but then when you stop, you go back up. And that's why exercise is so important. I know you do a lot of exercise. Good for you, Matt.
Yeah, if I'm honest, I control my weight through diet far more than exercise. I might think I was better at exercising if I wasn't married to my wife, who is a beast when it comes to exercise. She's really on point. Man, this stuff is really crazy. And one thing that I loved about the book is you walk people through, because you weren't flippant about the science. You would get a discovery and you'd be like, let's check it from 8 different angles. One of the ways that really hit me was vitamin C.
Yeah.
Walk me through vitamin C's role in this. We can't produce it, but it has like these huge effects. Like why from an evolutionary standpoint would it make sense for us to lose the ability to produce vitamin C?
Yeah. So vitamin C is good, right? It's an antioxidant. It's, so the big question is why would we lose vitamin C in our past? So we used to be able to make vitamin C way, way long ago. But probably around 60 million years ago, 65 million years ago, we lost the ability to make vitamin C. And it turns out when a fruit is being made, as it's maturing, it starts off with a high vitamin C content and a low sugar content. It turns out that vitamin C blocks the oxidative stress induced by the fructose because it's an antioxidant, so it blocks it. So fructose causes you to gain weight by creating oxidative stress, and that vitamin C blocks it. So when the fruit's immature, the tree doesn't want the bird to eat it because the seeds aren't mature. It's not good. So that it wants to wait till the seeds are mature. And so it will wait, and the vitamin C content will block, the animal won't gain much weight by eating an immature fruit because the vitamin C is going to block the fructose. But as the fruit ripens, the vitamin C goes down and the sugar goes up. And now it's good for the tree and it's good for the animal. And so they'll eat the right fruit. So it turns out vitamin C has a role in blocking fructose. And what we did is we took animals that could not make vitamin C, And you have to give them a little bit or they'll get scurvy and die. So you got to, all the animals get a little bit of vitamin C, but one group gets a little and one group gets a lot. And then we give them sugar, and they eat the same amount of actually high fructose corn syrup. And the one that has the lower amount of vitamin C and they got much fatter. Linus Pauling was right. We should all be on 500 milligrams a day. If you take huge doses, you can get kidney stones. So remember that. So don't take huge doses of vitamin C, but 500 milligrams a day is really good. And once you get up to a gram a day, it also may have some effects on exercise, which I talk about in my book. So, but 500 milligrams a day is great. And it turned out that when this mutation occurred, an asteroid had just hit the world, and there was a massive extinction. The dinosaurs became extinct, and their little primates that were living that time actually got this mutation. And my belief is that the mutation was a survival mechanism. So they at that point, they didn't make much vitamin C, so they were kind of in a low vitamin C level, so that when they ate a fruit, even if there was some vitamin C, it wasn't enough to add to what they were making so that they could make more fat. So that's the hypothesis. I mean, so, in my work, we have the hard science and then we have the interpretation. But I do know that if you have a low vitamin C level, you're at increased risk for obesity if you're an animal, and the data in people shows the same. People who are not eating a lot of vitamin C or have low vitamin C levels tend to be overweight. Vitamin C supplementation has been reported to help all aspects of the metabolic syndrome. So
it's insane.
Yes.
All right, walk people through really quickly then what they should be doing. Drink lots of water.
Yeah. So the first thing is, know your foods that can activate the switch and know the foods that don't. Vegetables, of course, are good. White meats, a lot of fish are good. Red meats, you have to be a little bit careful for. I wouldn't eat a lot of them. And high glycemic.
Because of umami?
Yes, because of the umami. And it also, yes, it's probably because of the umami that it has its negative sides. But basically, the most important rule is liquid sugar is really dangerous. And the reason is when you have liquid sugar, you drink a lot very quickly. And so the concentration is high as well as the amount. And what triggers the switch is the concentration of fructose the liver sees. So if you have a soft drink and you drink it in 1 minute, you're going to give a huge dose in a short period of time, and that means a high concentration. If you took that large soft drink and you sipped it, and you sipped it over 3 hours, it's just going to be a calorie. You're never going to get the fructose concentration will never get high enough to activate the switch. So if you did one sip every 5 minutes, I doubt you're going to activate the switch. And then, liquid sugars, you got to watch that. Fruit juice, I love fruit juice, but unfortunately, it will activate the switch for sure. And so I would not, I would be very careful with the fruit juices. There may be some fruit juices that are safer, like fruits that are really relatively low in fructose, like kiwi and stuff. There's berries, some of them don't have much sugar in it. And those might be fine. A third thing would be, obviously desserts and candy and sugar, cakes you have to be very careful with, and try to minimize. If my son has a birthday party, I'm gonna eat a piece of cake. So try not to eat too much of the sweets. High glycemic carbs, I think there's 4 big ones, right? Bread, rice, potatoes, cereal, chips. Watch those. Those are real. I recommend trying to avoid those if possible. If you're going to eat one, just eat. And then, drink a lot of water. I mean, one of the incredible things is most people who are overweight are dehydrated. And they're dehydrated not only from the salt, but it turns out fructose dehydrates you too. And I didn't go into that. But if you give a person a soft drink, that is not hydrating, okay? That is dehydrating. And you can prove it. And if you give animals soft drinks and you give them a lot of water, you can block the effects of sugar partially. I mean, significantly. So you should drink 6 to 8 glasses of water a day. Some people can drink 10 to 12, but you can become water intoxicated. And if you're a marathon runner, drink to thirst. And because marathon runners, if they drink too much water, they can actually drop their sodium concentrations and get really, really ill. Or immediately following surgery is another time you should not drink a lot of water. But for most of us, we're not drinking enough water, and we should be drinking 8 to 10 glasses of water a day. And that's probably one of the best messages. When you reduce your salt intake. And things like intermittent fasting is fantastic. That's a wonderful system. And low carb diets, wonderful for trying to lose weight. And then exercising turns out to be a great way not to lose weight, because it doesn't burn many calories, but it stimulates the mitochondria. You won't notice the benefit, except the benefit's going to be happening, because as the mitochondria go up, your risk for relapse and gaining weight goes down. So exercise, and it's a particular kind of exercise, we call it zone 2. That kind of exercise is really, really important. And it's something that I personally want to do more of. As a workaholic, that's probably the thing I have the hardest time, is finding that extra time during the day to exercise. But
no, I hear it. Well, you've been putting your time to very good use. I found your book utterly fascinating. Where can people follow along with you socially? Where do they get the book?
I have a website, drrichardjohnson.com, and that's probably my main site. And then, of course, the book's available through regular, all places.
Wherever good books are sold?
Yeah, wherever books are sold. And, I do have Instagram, Dr. Richard J. Johnson.
Awesome. Well, guys, the book is fascinating. I have become obsessed with what's going on metabolically, from the signaling molecule idea, uric acid. That whole alarm bell chain is something that I'm starting to pay a lot of attention to. I highly encourage you to read the book, to follow along with him. And speaking of things that you should follow along with, if you haven't already, be sure to subscribe. And until next time, my friends, be legendary. Take care. Peace.